Sure. So our next speaker is named Cherish Santoshi. He's a senior developer of relations engineer at Orkes, and he's going to be talking about API orchestration to build resilient applications.
Hi, Stephen.
And
Thanks for having me.
hey, Cherish, how are you? Of course. Yeah, I'll let you take it away.
Well, how are you guys? Yeah,
We're doing good. Yeah, it's been a great day so far. Everybody's had a lot of really interesting talks, and I've been here on this track, obviously, so I can't wait till it's over so I can go check out some of the other speakers from the other tracks. And it's been a great conference so far. So appreciate you being here with us.
of course. Thanks. I assume you guys can see my screen and my slides. And if there's anything, oh, great. I see it now. Perfect. All right. Cool. Thanks, Stephen, for having me, and thanks for the opportunity. I'm glad to be speaking at Apisecure. Or really wanted to speak at this conference. I'm happy I'm here. So today I wanted to talk about API orchestration to build resilient apps. So it's not none of these ideas are new, right? Like only the two things that here are could be new for anybody are just like the fact there's a new word called orchestration and there's resiliency. Now, to think deeply about both of these facts, that like we have to understand what orchestration is, and then what does it mean for any application to be resilient, right? We have heard of resiliency, but let's just explore what that would mean. We'll go through a very quick slide, and we'll try and make it as easy and as efficient as we can. 4 points to the agenda. The first is how we currently have API architectures, how they're usually managed. The second is what is orchestration and how what is different about orchestrated API architecture versus a typical one. The third one is how does orchestration help, both in terms of security and as well as resiliency. And the fourth is tools and methodologies we have particularly used to get this away, right? Just so without further ado, we'll just start here. So this is a typical API architecture, right? Like there's nothing here that we haven't seen. Pretty much, you can see a lot of different clients that are accessing the interaction layer, which is like an API or a service gateway. That speaks to the application layer, which has a lot of rules, regulations that further, have a lot of services attached to it. Could be analytics, security, developer, and so forth. So you can have all of this on on-prem or at cloud, and you can some of these could be also built monolithically, right? Now, an important thing to note here is that if this is built monolithically, like there are going to be some challenges, and we'll see how. But this is how things change when there's an orchestration layer added, right? Their end users, or they access the applications through, their own client applications. This is what we're trying to make resilient. There's a security layer, a caching layer, and then representation layer. Now, representation layer is important because it tells us how things look, visual elements of it, right? And that could mean that transforming of data could be required. Now, this is what the orchestration layer does, right? It makes sure that there is a bridge between the representation layer and the API implementations and how it ends up looking. And then the finally, implementations speak to backend systems. And we'll see how orchestration layer can have a lot of other nuances to make sure that your, application is resilient as well as secure. The next thing is that now, imagine like an orchestrator in your current architecture, and what happens if looking at how currently the teams, the architecture and everything has been distributed, and it has been distributed for a while. But what happens here is that if you have an orchestrator in between your microservices or APIs, what it could also do is that be language agnostic. So you have microservices that's written in Python with NoSQL, a database. The second one is in Java with Oracle, and the third one is Node.js with MySQL, and fourth with Go and InfluxDB. Now, all of them are speaking to the same orchestrator, which means that the orchestrator is language agnostic and is able to transform data from one service to another, have concurrency going on, because sometimes all of them need to be run in parallel, sequentially, however, and then give it back to client 1, 2, and 3. I'll give maybe like a quick second for anybody to absorb this slide. Perfect. Okay. So now looking at how orchestrators work and how they can speak to multiple APIs and how that affects, let's start with what is API orchestration, right? The first thing is that we want to know is that the word orchestration only comes into relevance when there are more than one players, when there are more than one API, especially when they're distributed, right? Because if there is data that needs to be split, merged, or rerouted, we need somebody who can do collect these moving parts and send them the right way. Now, this becomes extremely important because one of the things that we see about resiliency is that we need all of things to be available and highly reliable and also be secure, right? Like that's one of the things. Now, for that, having rerouting of the data is extremely important, right? Now, and we'll see how orchestration has a bunch of aspects that can be broken down and further explained, with much more nuanced. The first is data transformation. So you can see how, going back to the previous slide, right, like which we stopped at for a bit, there will be a bunch of data that needs to be gone from one place to another and could require a little bit of transformations in between. The second is going to be runtime management. The third is integrating language systems. Could be legacy system, could be a new, could be something that you're currently building and your next team could be building. The fourth one is authentication and role-based access control. This is where security comes into picture and authentication comes into picture. The fifth part is observability, debugging in distributed applications. Right now, I'll go into all of them, one by one in further detail. Starting with data transformation. Right now, imagine you have 10 different microservices deployed in 10 different, could be on-prem or it could different architectures. Right now, one of them is written in a fashion that has a different format. Now we know that some of the data that was sent or received in a certain format may not necessarily be rightly presentable to the presentation layer, right? So it could require some level of transformation at the orchestrator level itself. So this is where orchestrator kind of comes into picture, and not just transform data but also kind of make sure that if there are certain kind of operations that need to be done, some lightweight calculations or some kind of representation, minor edits and polishing, that's something that orchestrator can do, right? It can guarantee that it can intervene at the middle of the payloads, make sure that they are prepared accordingly how it needs to be consumed without worrying about another API or another function to kind of do that. That's one thing, right? The second thing is runtime management. Now, one of the ways you can look at runtime management is like a watch, like a guardian or person who's looking over the entire architecture with a very keen and careful overview of everything, right? Um, Now, runtime management is important because, like we discussed before, the splitting, merging, and combining of data can happen real time. And not just that, sometimes the APIs can hit sensitive and vulnerable areas of the architecture, especially backend systems, that needs a certain level of check at the middle. And this is where runtime policies, checking for malicious code and threats could be something that orchestrator can do at that level itself, so that the entire architecture is secure. And entire app, so you can treat everything as like a collection of microservices, right? So that's one thing we can expect in terms of runtime management. The next part is integrating legacy systems. One of the things I noticed while I was at one of the fan companies is that, um, like when it seemed like we had so many APIs and so many microservices speaking to each other, it seemed like a house of cards. So if you pick up one thing, it would break. Uh, and the reason for that was that to speak to one legacy system, which wouldn't scale, there was another system that was built that would scale to some level, right? But to make sure that both of them would connect, there's another API, there's another service, right? So there was just like a distributed monolith, if I may. And that's what happens sometimes when the orchestrator is not language agnostic. Some of these APIs that are in microservices that are written may not work well together, and this is where orchestration kind of comes into picture and ensures that everything that is already built and is currently being built kind of are on the same page, and if so that it's easier for you to scale up, right? It's seamless scaling if that happens. You don't lose data, and of course you don't lose any kind of legacy system. and they serve their own intended purpose. That's one thing. Now this is where security comes into picture: authentication and role-based access control, or RBAC, as we call it. Now, a lot of bigger companies who work at scale and who have distributed applications, they know that some of these, some of these areas, functions, and part of the systems are not necessarily accessed by, or could be accessed by, everybody. So the way to kind of mitigate that is that there is role based access control. So which means there has to be a layer between that checks for every API hit, and checks for authentication, and and some level of role access, to make sure that it has the access to what it's trying to, a response and the payload that it's trying to get. Now, the way you can do this are, you could build another service in between to do that, or you could have an orchestrator in the middle, like a layer like that, which will make sure that your entire API architecture, your microservice architecture, is secure as well as given to the right people. Right. So this is where RBAC comes into picture. Now, and the final part is observability and debugging. Now, this picture in itself is kind of self-explanatory. So you can see that there were about 22, bunch of APIs that were called. You can see how much time every API took. When did they start? When did they end? How did the next one begin? So you can see concurrency there. You can see all of them fired at once, and there was a join that joined all of them together. So here, note that all of these are basically API hits, and there's fork and join, which are system tasks. And what is system task? We'll kind of come into that into picture. And what is this screenshot is discussed next. So the screenshot is from something called Netflix Conductor, which is something that we use as an orchestrator here. One of the reasons we use Netflix Conductor, and there are multiple of these available in the market, you could, we just prefer this. And the reason for that is a lot of OS abstraction. So Conductor was built by Netflix and was made open source. So it's an open source tech nonetheless, which means anybody can use it anytime they want to, for free of cost, of course. And we really like the fact that it's the penetration it has in different kind of industry, which when it comes to media, entertainment, retail, fintech, and banking. And this is extremely important for us because when it comes to resiliency, security, especially when Apisecure comes into picture, this theme of this entire conference is that the data is so sensitive that the security has to be like the primary and forefront, right? And that's why looking at all of these things, healthcare, telco security, networking, and of course companies like Apple, Netflix, Tesla, a lot of these things wouldn't budge on their security aspect. So we really like the fact that this was picked up completely open source by these companies. That's why Conductor is something that we currently are using. One of so for you to kind of go back to the screenshot that I had originally presented, right? Like this is the workflow that we had built, and these are a bunch of APIs that were kind of ran sequentially, and you could have multiple APIs that run sequentially. A lot of times that happens, and you could have all of them kind of run in parallel as well. Something that is very quintessential and niche to an orchestrator. Have all of them run parallel, have all of them join at once, and then run again, right? If you're interested, and I see this got kind of trimmed off, but if you want to explore more about this playground, you could edit the entire workflow as you see it, or copy and expand on it if you wish to, using this link. So here's the link. You could kind of take a picture, or just have access to this if you're looking at it, or just reach out to me over Slack or whatever to kind of get access to this. Or if you're sharing presentations, we can do that too. Now notice that when orchestrator comes into picture, all the things that we spoke of, in terms of transformation, there's going to be transformation. There could be transformation from here to here. It could be lightweight operation, right? And if there is role-based access control, obviously there's going to be you could have a system task in here and make sure that every kind of request that comes into picture can have access to only one and not the others, right? So that's one thing. So the one of the reason why we use an orchestrator are of course for security and resiliency, but essentially what we've noticed is that Using an orchestrator and to build an API, secure API environment, you could also make sure that your architecture is stateful and also serverless. You could have all of them on prem or completely serverless as well. You could visualize things, which means that how we saw back that every API ran for a certain amount of time, and you could see when anything started, when anything ended, and where would exactly, if anything fails, you could exactly pinpoint where it is. So visualizing and debugging becomes extremely easier because it's there. And language agnostic, so you could have legacy systems built, or you could have all of them speak to each other. You can that allows us to scale seamlessly, right? Our hybrid and multi-cloud environments, I think, OS, cloud Conductor offers integrations with Azure, GCP, and any AWS as well. Of course, actionable insights, which means that if you can see how much time any API is taking to hit, how often is it failing, and what is the rerouting mechanism if anything fails, and these are actionable insights that is important for any kind of system to be resilient, which means high availability. And looking at what resilience means, it just basically means three things, right? There is going to be high availability, which means I should be able to access it anytime I want to. Reliability, I should be able to access it from any device I want to, whenever I want to. And the third is it should be secure. If anybody tries to access my system, it should be secure. Like, it shouldn't like create problems, right? So a lot of these insights kind of come very visually when you're using an orchestrator like that. And this is why I think like having an orchestrator for API orchestrator kind of makes sense. If you want to use any of these tools that I mentioned, you could use join our community. You could use that, or just we could discuss in general how API orchestration matters. That's our community link. You could take a picture, take a screenshot, scan it, and join. And with that, I think I end. And if you have any questions, I'm here to answer. Oh, here, I'll come back to the slide.
There I am. Oh, something's up on my camera. What the? Why the camera's so bright? There it goes. It takes a second. That was great. So if anybody has any questions, please put them into the Q&A. We have a little bit of time here, so I'd like to get some questions from the audience if anybody has any. In the meantime, can you talk a bit about debugging?
Sure. So one of the things that was bothersome for a lot of developers like myself was that um, when APIs would fall, right? Like you would like a Neanderthal, you would kind of wonder where this happened. Why are we getting to 404s? And especially in a distributed architecture, when a lot of APIs would speak to each other, finding that could have taken a lot of time. So DevOps engineers spend a lot of time kind of understanding what's failing, how often they're failing, what is the reroute mechanism, right? What really helped me to kind of understand how we could resolve this is essentially uh, wondering where exactly the fault lies. Now, it's if I show you a map and I show you that this area has a problem, you can understand that out of all the places that could potentially have a problem, you've singled that out, and the visual element of debugging makes sense. So having an observability layer, and like you could see how sequentially anything ran, when they failed, how often do they fail, what is the reroute mechanism, how much time it took, how many retries it took, what is the retry mechanism, what is the partial failure workflows that we can add. That helps with debugging in such a case that you could not only read out your your workflows, but also ensure that there is always like a backup for anything that's happening, right? And that helps with debugging a lot, not just the visual element, but also like a rerouting mechanism in terms of a workflow.
Nice. Yeah, definitely. But we have a question. Is MuleSoft an API orchestration?
Sorry,
Is MuleSoft an API orchestration?
I'm sorry, I is what on
MuleSoft.
more soft. um
Yes.
I'm not sure, I haven't heard of more soft yet. Let me just quickly check that.
Sure.
Mhm. But until meantime, I can pick up the next question as I quickly search for that.
Yeah. So again, please, anybody, any questions you might have, throw them right into the chat. We could start a discussion that would make this sure much more interesting for everybody. Also, in the meantime, talk a little bit about performance if you can.
Okay. So the idea of performance here is that we want to make sure that you know let's just understand the word performance. It essentially means that when there is a system that is being built, how many hits can it take at once? How often can it? How what is the frequency of it failing? What is the frequency of it being available? And what is the methodology if there are any kind of failures? What happens then, right? And knowing that like when conductor was built, it was one of the first ways that when Netflix took its entire architecture and make it microservice based, right? Which means, and we know that the scale that it operates at. So a lot of microservices that are necessarily it could be hit upon. We know that a conductor has the capability of ensuring that a lot of microservices that needs to be orchestrated, all of them could be done at once. One of the things about performance is that we want to ensure that our systems are not just available at all times, but also has the capacity uh, of picking up things which have like a RBAC mechanism, which has any kind of reroute mechanism in terms of anything fails. If that's taken care of, a lot of our performance is kind of heightened. Another thing that I want to take about performance is that we did a performance study on conductor, and we took how many hits it could take, what are the amount of workflows that it can run. We saw a bunch of testimonials that can a million workflows run per month on conductor, and if so, what is the performance there. There's a beautiful GitHub discussion about how many workflows can conductor run on like a or like any orchestrator for that matter can run in its 1 month or like in a day period. And another thing about workflows is that some of the tasks that you have, these are long running. So if you ever have had a DocuSign kind of environment where you have like a workflow that continues to run until both the signs are taken care of, so long running workflows. And if there is any kind of workflow that requires, hey, if you send me a contract and I say, hey, there's a change, the workflow changes. There's a dynamic workflow, right? The performance kind of changes. So taking that into consideration as well, that's another kind of case study that we ran into. So that's something that we have done a quick study of. You can find more about this on our GitHub discussions, and most of these answers can be found there. If you still think there's a lot of open questions there, I would love to hear and kind of discuss it with you.
Great. So again, any questions, please put them in the chat. In the meantime, until maybe some of our viewers have questions, I could toss you a few softballs, talk about your background. I know prior to you working at Amazon and Hacker Earth, you actually founded Black Eyed Labs. So can you tell me a little bit about that? Let's go back a few years. I'd like to hear about that.
Sure. So one of the reasons we did that was I like to give back to the city that I'm from. I'm like very grateful for. I come from a city called Chandigarh in India, and it's one of those cities which was the first planned city of this country. And it's unlike any city in India, right? Like it feels like completely European in its sense, because the maximum height of a building is like 3 floors at all. So I'm so attached to the city in some sense that I really wanted to find ways to give back to the country, to the city. So the primary reason for founding Black Eye Labs was that I wanted to build applications that the government and the citizens could enjoy or use. So what we did was that we found, and the houses there are unlike how the rest of the house numbers are in India. So there's a house number and there's a sector, and that's it. So house number 7, sector 3, that's it. Which isn't the case in the rest of the country. So we built an application because the rest of the country is like this street, that lane, that society, that area. But we founded that the entire idea behind Black Eye Lab was to make smart governance and make sure that the applications that we have built are something that citizens and the government could enjoy. So I founded that on basis on that. We built an app, we built a bunch of small and medium applications for the government, which were added late, which government took from us, for and they added that as a module to our smart city app, which was an initiative launched by the Prime Minister of India then,
Wow.
and which was great for us because I feel like we added an impact to the city that's going to long lasting, that will kind of outlive me, and we have a legacy that we have given back to the city.
Absolutely. Yeah, that sounds wonderful. That's great. And to have a legacy like that is also great. I'm sure that feels so great. So that's just amazing. So I also know, speaking of you building things, you've built a community of, tell me if my numbers are correct here, almost 5 million developers.
Yes, so I joined Hackerearth when they were at 3. We scaled it to 5 while I was there.
Wow. That's great.
Yeah, I think like I take pride in that. I think I had a huge team to kind of like do this with us, and we built that community from 3 to 5. It wasn't an easy task, but I think it was surreal to see like those numbers in its sense, because if you're growing something of that mammoth scale, you obviously have a lot to lose, so you have to step everything very cautiously. That's one thing that we did when we were at Hackerearth, and we're pleased to see how it's doing now. And again, like going back to that, leaving my legacy and leaving a mark everything I touch. I think one of the systems that I added at Hackerearth is that this, if you look at hackerearth.com/challenges, you'll see a bunch of tasks, a bunch of things there on the top right corner. Hackerearth ads, we used to call them. I launched them there, and that helped us grow our community as well.
That's great. So when you started and you were building it up from 3 to 5, was it, almost like an organic process that you guys were just kind of doing different things here and there and it organically happened? Or did you have a kind of a plan and you were like, this is how we want to attack this, we want to grow our numbers, and this is how we're going to go about it?
Sure. So there are two ways to think about this, right? Like anytime, so Hackerearth's model was such that there'd be a client saying that I want to do a hackathon or hiring challenge on your platform, and you have a community. Why don't you like facilitate that using your community? So so Hackerearth would take a management fee to kind of facilitate that information and make sure that the brand gets what it deserves and what it's paid for, right? Now, there are two problems here. One is that we are limited in our offerings, so we can only do hiring challenges and hackathons. And the second is that there could be something that exists out in the market that the developers want, but they're not getting it because there's no client ready to pay for it, right? Which means there has to be a bunch of challenges that has to be ran in-house, internally, organically, spent resources in-house so that developers get what they want. So if they want to do, I don't know, let's say Web3 or Go based hackathons, but there's no client paying for it or there's no deals as such, why would you do it, right? But you realize that you have to give back to the community for them to come back and make sure that they stay on a platform for far longer. And I think we did that. We had a bunch of Hackerearth sponsored, Hackerearth ran challenges and hackathons to kind of increase that. And then finally, that made us see the growth in the community kind of increased. Our challenges page saw more of retention time, more sessions, and then that gave us the idea that now we have grown the community, right? Now we took those numbers and went back to other businesses saying that, hey, if you have anything beyond the current offering, which is hiring challenges and hackathons, you could tell us that as well, and we could add that as a ad that people can see as like a banner, so that if there is any other offering out in the market for developers, they are at least be able to access that and have visibility into that.
Yeah, they're aware
That
of it.
we gave the developers what not readily available by giving them what they initially wanted, and then using that traction to find more opportunities for them that they would enjoy.
That's great. Yeah, it's great. I just want to remind everybody that please, if you have a question pertains to Cherish's talk, throw it in the chat. Otherwise I'm going to keep asking him random things that might not be related, but things that interest me. Also, I apologize if I've butchered the pronunciation of your name. Sometimes my Brooklyn roots show and I can't pronounce names properly, but I believe I did. It's Cherish, correct?
Yeah, it's like the English word how you cherish something, right? It's
Okay,
the
that's what I figured. Yeah.
yeah, that's right.
So let me ask you, and when it comes to bug bounties, do you
Mhm.
believe that going about them with learning as your main priority is kind of a better strategy for it, as opposed to attacking it solely on the basis of I want to find this vuln and get paid for it? How do you feel that going about it with financial motivation as kind of like secondary, as opposed to what you can learn from the experience, will create a better experience for the bountier?
I see your point, right? And it's an interesting question. That the question here is that would you try to find vulnerabilities into system only if there is financial motivation? I mean, did I
Essentially.
right?
Kind of. Well, really, not so. I mean, obviously, the financial motivation behind bug bounties is a driving force to it. But I know for me, I'm only I'm less than 2 years into my cybersecurity journey. So getting into things like bug bounties is a great way for me to learn. And I know a lot of new people that I've spoke to have said similar things, just kind of dipping their toes into the water. But I know that there's few different types of kind of bug bountiers, if you will. There's people who try to make a career out of it. There's people who are in it just for the learning aspect of it. So my question really is, what do you think would make more successful in that field, if you're solely going after the money, or if you're doing it because you want to expand your skill set?
Hmm. Okay. So here's the thing, right? Like now let's look at how cybersecurity engineers are different from like a Java engineer or a JavaScript engineer. The way so bug bounties, capture the flag, all these events are essentially a way of competitive programming,
Mhm.
which could take its shape and form in solving algorithm problems and things like that when it comes to JavaScript, Python, whatever, right? So there you have algorithmic problems, problem solving problems or complexity problems. When it comes to cybersecurity, well, you have all the tools in your hand, but essentially the way to compete here is to find ways and look in areas that nobody would look at, and find ways to solve which is very problem solving methodology, but it still allows the scope for to compete against each other. Um, i think developers inherently are competitive, and cybersecurity engineers are no I think no different. They also like competing, and I this is why the kind of industry really grows, that they're always competing at a level that it's going to be hard for hard for anybody to kind of level up, match up every now and then. Of course, like you said, having capture the flags, bug bounties makes sense if you're approaching it from a learning angle. Of course, why not? But the idea that I want to compete more than you, which is the inherent developer drive in some sense, makes it fun when there is more swags or financial
Yeah,
motivation or some kind of incentives that is added. And I think it also is a huge driving factor for a lot of other new developers to enter. You could be saying that it doesn't matter because it's a learning endeavor for you because you're early in the system, but I know a lot of people in college who pick up hackathons because there's rewards to be won.
definitely. Yeah, and of course, the scoreboards and leaderboards and bragging rights and all that definitely factor into it. So, like you said, a lot of engineers are very competitive,
Yes,
and there's nothing wrong with that.
absolutely,
Competition
it's great.
competition breeds productivity. So
Absolutely. Yeah,
yeah,
and we appreciate that. I feel like competition in this sense has been not just healthy but also necessary for like innovation.
yeah, I agree, 100%. So again, I'll remind everyone, please put some questions in if you have them. Continue the discussion. Um,
I can always take these questions over Slack, and I think that's
Yeah, yeah, and if anybody would like to reach out to Cherish, please, his information is online. He's on LinkedIn, all his socials, and I guess with that we'll wrap a bit early. Cherish, thank you so much for your time. This was great. I really enjoyed talking with you.